Okay, let me see if I can go through 7, 8, 9 rather quickly here. So number 7 says, based on the equation below, what is the value of y when x equals 5? Well, it's a pretty straightforward problem. You're going to replace the x with the value of x, which is 5, and solve the equation using order of operations, or PEMDAS, which some of you are kind of groaning right now, but let's do this. This is okay. So for x is equal to, oh, that's messy. For x is equal to 5, we're gonna let y equals 4 times 8 minus, instead of x I'm gonna write 5 squared, and well, right underneath this, 8 minus 5 is 3, so it's going to be 4 times 3 squared. 3 squared is 9, so it's 4 times 9, which is 36. Y equals 36. So we see if we have that as an answer. Yep. Part B, y equals 36, right there. So number 8, if I can get this down there, I'm gonna bring this over. So number 8, exactly 3 diagonals can be drawn from a vertex of a given polygon. What is the total number of sides of the polygon? Your choices are 3, 4, 5, 6. So 3 is a triangle, 4 is some type of square, 5 is a pentagon, and 6 is a hexagon. So let's draw these out and see if that makes anything a little clearer. So this is a triangle. If I was to draw a vertex from any vertice from any of the vertexes here, well, it would just connect the sides, and that doesn't count as a diagonal, so I can't use that. How about a square? Well, if I was to draw a diagonal from one vertex to another, I'd have one diagonal. There's actually 2 diagonals in a square, but pretty much the question was asking from each vertex, which means how many lines are coming out from each corner. So for a square there's only one. Next shape up has 5 sides. It's a pentagon. 1, 2, 3, 4, 5. And if I was to draw diagonals from this, I'd only have 2 diagonals. So obviously the answer is the polygon with 6 sides. And if I draw diagonals from each vertex here, I'll notice I can draw 3 diagonals from each vertex. That means from this vertex I can draw 3, this vertex I can draw 3, this vertex I can draw 3, so on and so forth. You get the idea. But so D is the answer to that. Let's look at number 9. Number 9. Ooh, I've seen this one. I've seen people get this one wrong too. So the number of pages that Millie read on the first 7 days after she got a new book are shown below in the box below. 15, 20, 15, 45, 30, 35, 15. What is the median number of pages Millie read per day for the 7 days? Well, median means middle, and I've seen people pick the 45. Let me switch out my tools here so I can highlight some things. I've seen people pick this as the middle value, but the problem is these aren't in order. They go from 15 to 20 to 15. when you're picking out the median, the numbers you're using have to be in order first. So let's do that. Let's put all those numbers in order. So let me bring this, where should I bring this? Bring it over here and I'll try to write the numbers. So my first number is going to be 15. Second number is 15. Then I have another 15. Just had an idea here. I'm going to bring this over so you can see what I'm writing and bring the problems to my left. So I have 3 15s. Up next is a 20. Then after that comes 30, 35, 45. And from that you can easily see that the number in the middle is 20, or the median is 20. If I want to double check that, there's 1, 2, 3 on the left side of the median and 1, 2, 3 on the right side of the median. So yep, this cuts it in half. This is the median. And bringing the problem back, let's see if that's an answer. Yep, 20, choice B. Next problem, number 10. Yeah, I'm kind of having issues with my computer right now, but problem 10. Let's see if I can bring this over without shrinking it too much. So, it says, which of the following is equivalent to the expression below? The expression below is 3x squared plus 2x minus 8 subtract 2x squared minus 4x plus 7. So this is addition or subtraction of polynomials. So basically line up the things with, or line up the like terms. Anything with an x squared, you're going to line it up with something else with an x squared. Anything with just an x after it, you're going to line up with something else with just an x after it. Something that's just a number like this, you're going to line up with this. And I'm going to do that right now. What you have to notice here is you could just distribute this negative sign into everything inside this polynomial and make everything change signs, which means the 2x squared is going to become negative 2x squared. This is going to become positive 4x, and the plus 7 is going to become negative 7. So let's see how that works. Okay, maybe not so much. I'll bring this over. Let's see, I need to clear this out, I think. Alright, now that I have a clean slate and a clean sheet of paper, so this is what I have. 3x squared plus 2x minus 8 minus, in parentheses, 2x squared subtract 4x plus 7, close parentheses there. And now I'm going to change colors. I'm going to need to change colors so you can see what happens here. Ooh, I shifted my piece of paper, so that's going to shift everything I write around a little bit. So I'm going to change colors. Oh, purple. Go with that. Now this minus, I'm going to distribute and make it a little bit longer. So this becomes negative 2x squared. This becomes positive 4x. This becomes negative 7. So when I add those together, this is what happens. Negative 8 plus negative 7, that's negative 15. Positive 2x plus 4x, that's 6x. 3x squared minus 2x squared, that's positive 1x squared. You can write the 1 there or leave it out, it doesn't matter. And that's my answer right there. Let's see if that's written in there. And if I bring that over, yep, it's right there. Choice A. So I'm going to stop this video and start another.